As we've explored how to generate our sprite sheet animations, I do want to point out one important thing. So we have start end, and this is referring to the start and end numbers as they appear in the JSON. So we have 1, 2, 3, or over here we have 1, 2, 3. So that is what those numbers refer to, because we are generating frame names. So this is an easy thing to overlook as looking at when we are using a sprite sheet without JSON. So we just load it as a sprite sheet. We don't load it as an atlas. Then we are generating frame numbers. And then those frame numbers, such as in the phaser-based tutorial, start out at 0. So the first sprite in a sprite sheet, when we use load sprite sheet, not load atlas, is going to be 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Those are the 9 sprites here because counting starts at 0. So that is an important distinction. When we are using frame numbers, we count the first sprite position as 0. But when we are using a sprite sheet, then we go based on, or an atlas with that sprite sheet. As we read from the JSON, we are going for a name. So we're looking for how is it named. So in the JSON, if it had different numbers on the name and I wanted to start like 3, 4, 5, 6, then that is what I would use for the numbers under start and end. So it's a subtle but critical distinction when we're loading an atlas versus loading a sprite sheet. Going into the player, so because player is being loaded as a sprite sheet, not as an atlas, so we don't have any JSON to go with it. So if we look at that sheet, we will see that each one of these sprites corresponds, so that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 12 per row, and then we're grabbing this as one of the first sprites when we look in the player, so we can see that's why it's at 60 and 62. So we had to go and count on each one of those characters. We had to figure out what number that sprite is in the sprite sheet. This is why using an atlas is so much easier, because we can, one, come up with names to represent it if we've represented the artwork correctly when we bring it in, and two, then we don't have to have all these, kind of counting our way across. So if we spend a little bit of time on the front end naming the individual sprites that will make up the sprite sheet, use Texture Packer to then put it together and write the JSON, then we're going to be much better served by loading an atlas instead of a sprite sheet. Moving forward with this, we're going to create the enemy so that the player has someone to interact with. And in doing so, we're going to use the sprite sheet and JSON that was made by the online free version of Texture Packer. So I'm going to get rid of this other atlas. I'm not going to use it anymore. And I am going to then get rid of that code there. And we're going to get rid of this here. Okay, so let's save. No error messages. We got our sprite there. He's walking along happy as a camper, so that's good to see. So this is some of the information that we are going to be bringing into an enemy class. So the enemy class is going to be very much like the player class. So it's going to extend entity, it's going to have a constructor, it's going to make its animation, set any other properties that it needs, and then it will have to figure out how it is going to wander through our game environment. And then once we have it wandering, then we will work on building some of the intersection so that when we have the player and the enemy intersect, we make something happen. So that's our next series of steps. So the first thing under scripts, I will just add a new file. This file will be enemy.js. And now that I've created that file, we can start populating it. Class enemy is going to extend entity, curly brace. Now I will have my constructor, and I will pass in my scene. I will pass in an X and Y where I want it to show up. I'll pass in the texture key I want to use. Eventually we will have some other values that we pass in, but this will be enough for us as we begin the process. So every time we extend something, we will have to call super, and then we will see we have a few options here. So it wants scene, X, Y, texture key, and we'll pass in what it is for the type. All right, so this gives us a good starting point. We can start populating some of these things with the character or with the information, just like in the player. So we're setting up our anims. And this also is revealing that we perhaps will want to extend our entity class or add some more to it, so we're not repeating some things here that we're also repeating in the player, because we're using both frame rate and anims there. So we might want to set things up differently. We could even add the anim frame rate to our constructor, so we just pass it in, because then we could have different frame rates for different characters. No, we don't have a type yet, so we're not going to worry about type damage, but we do have a texture key, and our texture key will pass that in. And now the fun part, anims, create, and this is where we get to populate it. Now if we go back into our game scene, we will see some things that we are populating it with, and I'm going to just copy this code here and go into the enemy, paste that code in, and I will first start out, and what we can do is say enemy left, and we're, instead of specifying hard code in there, since we're passing in a texture key, because by leaving this as a variable when we pass it in, what it means is we could have a different sprite sheet for a different character, and we could pass that in when we create an enemy so that we would be able to work with it. All right, well, we want to do left for the first one, since this will be our left PNG. It's 1, 2, and 3, 0 padding 2. Frame rate, not as 4, will be our, yeah. So our anim frame rate, repeat, so there we go. So this now gives us our first animation. 3, 4, because we have 4 of them. So we have, so alt click, this will be right. Alter option click, this will be up. And finally, this will be down. So we've now created the 4 animations that we're going to need for our sprite here. And next thing will be to see about adding our sprite to our project so that we can watch the whole thing work. So let's see, this is the end of my class. This is the end of my constructor. And we will also have an update method. And update. So we're getting some of these things pre-populated in here ready to go. And what I'm going to do is just say this .anims.play. And in this, we're by using this here, because when we're at the main scene, this is where sometimes using this gets a little bit confusing. But when we told our sprite, this adds sprite, so we're telling that sprite, and then we're calling the animation manager and telling it to play that animation with that sprite. So in this case, this is referring to the enemy. The enemy is a sprite, so we're telling that sprite to call upon the animation manager, which is anims, which we've defined up here is our scene.anims, because the animation manager belongs to the scene, and then we're going to tell it which one to play. And I'm going to tell it to play one we haven't had running on the screen before, so we'll be able to verify that it's new, and it will be enemy down. So I'm going to save that, pop over to my main game scene here, and we are not going to be using any of that code anymore, so we're going to get rid of that. And now we're going to just change this and call this enemy. And I want to put another just line of slashes just to make it easier to verify that we are at that point in our project so that we can see it happening. And instead of saying this .add, what we're going to do is say this .enemy, which also means we are in up here, so we want to store a reference to it, so this .enemy, and now this .enemy is going to be equal to a new enemy. Right now we're just making one, and we can see the code hinting is helping us here because we have the class defined. The code hinting is telling us the items that we need to pass into it. So the first thing we need to pass into it is going to be the scene, which is referenced simply by this because we're in the scene class file, therefore this refers to the scene. When we're an enemy, a straight this refers to the enemy object, not to the scene object. I know it gets a little bit confusing sometimes, and that's why there are occasions where we will then set a variable so we don't have to keep using the word this, but that we can just use a variable name, so it gets a little bit less confusing in the code, but it is what it is. And then I can pass in a location for it, and I'll put it there. The texture that we pass in is TP online with it, so then that gives us what we are working with there, and we can see again that is the name that we've used for it, so I'm going to use that name there. Going to close that because we don't need that sprite anymore, because it would fail because TP on right animation doesn't even exist, so then it would get seriously grumpy if we tried to run it. So now I can save this and see what is happening in our project. And apparently we need to relaunch it. Pull it out. Let's go close the other one. Uncut reference, enemy is not defined, line 64. So if we go into our code line 64, it says enemy is not defined. Now the enemy, not lowercase enemy, capital E enemy is not defined. And that makes sense that it's not defined. Oh, and I see the server stopped because when I click back to this window, I probably clicked right down here, which then turned off the live server. That's why we had to restart it. So we haven't defined it, except that we have, because here we have the class. There's the enemy class. I don't need that graphic there anymore. Just going to get rid of the JSONs, just cleaning things up. But enemy class, it's been written. We can see it. But game scene can't see it because we never loaded it. So we have to load those scripts if we're going to use them. And now this portion of the process of having to hard code these into the HTML so it knows to load those files is something that if we eventually go to using some tool like Parcel or Webpack that allows us to have a configuration file and bundle things and then use imports and exports, then we wouldn't have to keep adding these to it. But that adds in another layer of complexity that I don't want to deal with right now. So now, let's see, it's unhappy at line 11 inside our enemies. So let's click back over to that and go into enemy and take a look and see what is happening. Now, if we remember when we created the player, we had this exact same thing happen, because if we look at this, because we defined anims as scene.anims in enemy, same thing, so we have to remove where it says this. So we have to get rid of the reference to this in each one of those. 1, 2, 3. Oh, there's my fourth one. So now that's gone. Save it. No error messages. And there he is. And our enemy is walking downward, which is pretty flippin' cool. So we've made some good progress here, but we do need to figure out now how to get the enemy to start moving, because we could give the enemy some velocity. So it can go this dot body dot, it's going down, so we'll give them a downward velocity, set velocity, and x will be 0, and I don't want to hard code a number. I want to use a value. So this means I'm going to go back up in my constructor before the anim's here and put in a value for speed, and we'll just set it. Now I want my monsters to go slower than my characters. Actually, I'll move it down there just so it's in that location. Well, so let's go down here, paste it in. Let's see what happens. Go here, and now you can see he's walking down the screen. But, you know, a funny thing's going to happen as he walks all the way down the screen, because he's going to keep walking on down the screen until he disappears. So that means we need to figure out how can we get our enemy to stay in our world. And we're going to do it in the same way that we don't need that anymore. We might as well, you know, keep our code a little bit cleaner as we work. The same way that the player has a collider with the world layer, the enemy can have a collider with the world layer. So it's going to be physics dot add dot collider, and then we specify this dot enemy and the world layer. So now if I save that, let's see what happens when it gets down here. And we can see how it is stuck and is not leaving the screen. Now he hasn't turned, hasn't done anything else. So we do need to figure out how we can get the enemy to start changing direction when it runs into or collides with the boundaries, the edges of our screen or our world layer. And we're going to do that by using the body blocked property. So to explore how we can work with this, the first thing that I am going to do is set up our enemy so that it wanders into a random direction. So we're going to use the standard JavaScript random number of math.random. I want 4 values. So random gives me a value 0 to 1, times it by 4, round it down, so that gives me possible values of 0, 1, 2, and 3. So I will use that to then switch through the 4 possible cases. So I will write a switch statement, and I'm going to switch based on direction. And in the case of 0, then we need to figure out body dot set velocity. So 0, I am going to go, we'll just follow the kind of the cursors, or actually we'll do WASD instead, just for something different. So that means we'll go up for our first value. And now we have 4 possible cases that we are going to work with. And then we'll have for 1, 2, and 3. And so we have, this is going to be up, and this will be left, down, right? So WASD, so left is going to be negative speed and 0, so we'll get rid of the one at the beginning here. And then down is going to be 0 and a positive speed, and right is going to be positive speed for the X, and the Y will be moving 0. So now and we're just going to kind of clean up a little bit of the formatting so it's easier to read. Well, too far. So we have our cases, and then we have we don't have a default case because, well, it'd be impossible to get something, but we'll just leave that there. So this now switches our direction. So instead of using the statement here, we will change that. Instead of playing down, so let's move this into the down category right there. Move it over. Copy that. Paste. Probably could have put these in the beginning as well. That would have helped. And now when we go through here, then And this one is gray, I'm noticing. And it's like, why is it gray? And it's because I put it after the break. And VS Code is telling me it will never reach that line of code. Therefore, that's why I put it gray. Now I put it up here. Now we're in better shape. So now I can just change that to up, not up. This would be left. Leave down as down. Now we have right. So this means it's going to randomly choose a direction, and then it will move off in that direction until it hits a wall. No error messages, okay. Let's refresh. Okay, refresh. And refresh. Let's see, keep refreshing until we get a left. There we go. So we've seen it now move in all 4 possible directions. We'll watch here, it's going to run into a wall, so then that's good. So this now gives us a wandering monster. The monster is going to randomly start moving in some direction as part of the constructor. Our next step is going to then be to deal with when it runs into the walls and its body is blocked by a wall, and we're going to figure out what possible directions remain beyond the direction that we're currently going, and then we're going to go in a different direction. To determine when the enemy has run into the wall, I'm going to log out so we can see the property we're using, and I will say this.body.blocked. So we're going to log that out. Now I've also increased the speed of the enemy here a little bit so we can see it moving faster so we don't have to wait as long. And we'll see that block gives me values of none, up, down, left, and right. So we can see we're not being blocked and all of those are false. So what we want to find out is when the enemy has encountered or run into the wall. So to do that, we need to set a few things up here. And with that, I'm going to use destructuring. So I'll say const speed is equal to this, and that is the output of that is simply this dot speed. Now I don't have to keep writing this dot speed. I can just write speed when I'm assigning my speed value. I'll just simplify things a little bit for us. You can look up JavaScript destructuring. The Mozilla resource for it is quite good. Now I'm going to set up enemy blocked is going to be equal to this.body.blocked. So I don't have to keep writing this.body.blocked. I can just say enemy blocked. Now that I have set this up, I will start out with an if statement, and I want to find out if enemy blocked dot down or enemy blocked dot up or enemy blocked dot left, not log left, or enemy blocked dot right. So if any one of those occasions is true, now what we'll do is we'll just log out enemy blocked, because that way we can see the change happen. So now when we're here, when we hit the wall, nothing happened. So it'd be a little bit frustrating, but what we have to remember is in our game scene, we tell the player to update, but we've never told our enemy character to update. So as I was noodling around in the code and adding some stuff into the update, saving, I'm like, why is it not showing up? Why is it not showing up? It's like, oh, I never called it. So now let's call it. We'll see there's our original, and when we hit the wall up here, it popped out blocked again, so we can see none is no longer true. but it's false because we are blocked on our up edge of the enemy. So the enemy's up has encountered a wall, it's blocked and prevented from moving any further. So we're in good shape. I'm just going to close entity because I keep wanting to click on that instead of enemy. All right. So with that, what we're going to do is we are going to create an array of the possible directions we can go, and then we are going to randomly choose one of those other remaining directions and then head off in that vector. So we're able to see we have the directions, and when we run into a wall, it spits out another direction again. So if it went left, left is true. So looking here, we'll see that this is a key value pair object. We want to be able to randomly grab individual ones out of that. There's lots of ways that we could achieve this. What I'm going to do is say let possible directions equal an empty array, and we're going to populate that. And what we can do is we can go through this blocked object and pull out all of the keys, because those keys correspond to the directions that we would potentially want to move. So I will say I'm going to grab for each direction in enemy blocked. What I'm going to do is take possible directions, and I will push, because it's an array, so I can push into it each direction that we are working with. So we have each direction, we can push that into that array. So to see what is happening there, now let's log that out. And save it. So there's our original. And now we can see it logged out, none, up, down, left, and right. So it now gave us all of those possible directions. Now, we do have a couple options here. We could get rid of none. We could get rid of the current direction that we're going, because we can figure out which direction was blocked, and we could not use that one when we create possible directions. That's one thing that we could do. Or we can just say at 60 frames per second, if it repeats the same one more than one time, the enemy may hesitate for a moment on a wall or corner before it moves into a new direction. That's very possible there. So we'll just create a value to hold our new direction, and what it will be is out of possible directions, we are going to grab a random one. So math.floor, parentheses, in the parentheses, math.random, parens times, in this case there are 5 elements in that array. Now if we never wanted it to grab none, well, notice that when it returns that, it put none at the beginning. And if we were to have it bouncing off the walls and keep logging this out, we'd see it always does it in the same order. So it's always none, up, down, left, and right is the order that we are working with here. So because of that, we could just grab 4 values and then take whatever one we're working with and add 1 to it, because the array positions are 0, 1, 2, 3, 4. So 1, 2, 3, 4 correspond to the array positions that we're going. Or we can just let none be part of it, because maybe we want it to, if it pauses for a moment, it pauses. Now, with this, we are going to use this same switch statement. We will add none into it. but there's no point in rewriting all of that since that gives us what we want. So based on new direction, and now the cases that we will be working with. So if we notice here, it's up, down, left, right. So I want to say up, down. Now, do I have to have it in the same order? No. Up. Oh, actually, if I'm matching this, I should do up, left. Duh, instead, and I forgot, since I already had this done. Normally, I build the switch and then populate it. So, but since I am recycling one, I have to pay closer attention. And even if the words didn't line up with what's happening here, it still gives us our different options right there as we work with it. And if we want to do our final case for none as we work with that, then I will just add it in. And we'll pull that back over there. Well, looks like pull everything over except for this break we can just stick over there. And so this right becomes none. Our speed becomes 0, 0 because we're not going anywhere. And then we can tell it to stop whatever animation it's currently doing. Now we could even tell it to play a specific frame of so we could set a frame from an animation, so we could do that as well. So we could go grab an idle frame. Ideally, we would even have idle animations so that as we build the complexity of our game, beyond just having the 4 walking animations, we may want to have an attacking animation. We also may want to have the ability to have idle animations for each direction. So these are all features and functionality that we can build into our project. So because we're just choosing, when we are blocked, we're just choosing a random direction. Yeah, we could just choose a random number and put those random numbers in and then just go here. But I like the possibility of perhaps we don't want it to, we want to know that it's not going to repeat the direction that it's going. So now we can log out all the possible directions each time, and that's going to keep giving us the same value here. What's going to be more interesting is looking at enemy blocked. We'll see that changing each time. So I'm going to just delete that so our console doesn't get quite as filled up. So now when we hit a wall, we can see it moved, and we can see how blocked is changing each time for which item is true on it. And we can also see how it repeated a few times. So down it repeated 3 times in a row. And so sometimes by not checking for that, but we're not seeing So it's parked here. It's not animating. It's standing against a wall. So this is where we stopped it, and it stopped. So we probably don't want to deal with none as part of it. And because we know that none is always going to be the first direction, then I guess we can just go for. So we choose a random number 4, and then so that gives 0, 1, 2, 3. Then we add 1 to it, so that gives us 1, 2, 3, and 4. So that means we should never draw none on it. So now I'm going to speed up. So it walks faster, having more wall collisions. Now let's watch what happens here. It's the wall. So now we should never find an occasion where it's struggling. And to make our logging a little bit easier to verify what's going on. Instead of logging enemy blocked right there, what I'm going to simply do is let's log new direction so we can verify, and then this way we'll verify we're never hitting none as part of it. So having let it run for a little bit, it's not getting trapped, but we'll see, you can see the repeats where repeats are happening. And we can also see in our map some of the problems of, if you're not careful in your design, you may find that characters get stuck in certain places where it starts wrapping into a corner, or in this case just wandering side to side. That's really disappointing that it's not choosing to do anything else except mostly doing left and rights. But there were a few up and downs, but then when it tried to go, it couldn't go anywhere. So we now have it working. It's running pretty quick. If we had a whole bunch of these enemies on screen, that would be problematic because they would then be crashing into us and we would be freaking out. But that does bring up where we are going to be moving to shortly. So the next phase of this is to go from one enemy into a group of enemies. And once we have a group of enemies, then we can really start expanding upon this project.